SOLIDWORKS Design 2026 brings you enhancements across the portfolio. In this video, we'll focus on the new functionality coming to SOLIDWORKS for structural simulation. Whether you're working on a simple part or a complex assembly, integrating simulation into your workflow has never been easier with SOLIDWORKS 2026. Here, we're looking at a subassembly that supports and stabilizes the rear of a horizontal drill, while also withstanding excessive thrust force from the drill head itself. This study is almost fully defined, using a mix of shells, solids, beams, along with some pin connections. To complete the setup, we need to apply the main load from a large hydraulic cylinder. A remote load is the best way to represent this, but until now, it's been restricted in where it could be applied. New in Simulation 2026, remote loads and remote masses can now be applied directly to shell edges. For engineers analysing sheet metal or thin plate structures, this makes it much easier to replicate real-world loading conditions. Looks like something's missing. This study isn't fully defined. No problem. In Simulation 2026, the error dialog now tells you exactly which body is missing a material or which mesh control caused the issue. This makes it much faster to set up problems, especially in large studies with lots of components. The horizontal driller is massive. It weighs about 22,000 pounds and can exert a forward thrust of nearly 28,000 pounds. Because it often operates on uneven terrain, we're analysing worst case conditions to ensure the rear support structure maintains stability. The analysis is complete, and we're reviewing the results starting with the displacement. Displacement plots are always a key metric, and new in SOLIDWORKS Simulation 2026, users can now define rotational displacement plots relative to the X, Y and Z directions. These are reported in either radians or degrees. In this case, we see significant rotation that could cause operational issues. This model is set up using primarily shell elements, ideal for analysing thin plates while ensuring fast solve times and retaining accuracy. Typically, a thickness to span ratio is used to decide between thin and thick shells, where thick shells will account for shear stress through the plate's midplane. New in Simulation 2026, you can now set the default shell type directly in your simulation options, with thick shells as the new default. To reduce rotation, we can adjust the plate thickness through the shell manager. Increasing the load-bearing plate to 5/8 inch and rerunning the study shows a substantial reduction in rotational deflection, bringing performance within a safe operating range. But static loading is only part of the story. During drilling, dynamic forces can introduce additional stresses. That's why we've created a random vibration study to identify potential resonance issues. New in Simulation 2026, connector reaction forces can now be calculated in dynamic response studies for pin connectors. Since this model relies heavily on pin joints to transfer loads, understanding how they behave under vibration is critical to designing a robust structure. With Simulation 2026, engineers can innovate with confidence, turning complex challenges into smarter, stronger, and more reliable designs. Every design is more than geometry, it's an idea brought to life. With SOLIDWORKS Simulation, you don't just model your vision, you test its strength and prove its performance before it ever leaves the screen. And SOLIDWORKS Simulation 2026 makes it easier than ever to get it right. Buckling analysis is a critical step in understanding when structures may fail under load. Let's take a look at this frame that needs to withstand 40,000 newtons of force per beam, or a total of 160,000 newtons overall. This study is almost fully defined using joint groups, material, fixtures and gravity. To complete the setup, we need to apply the acting force on the top beams. In SOLIDWORKS Simulation 2026, you can now define total force across multiple beams, or apply a distributed mass per item, giving you precise control over how loads are applied. This enhancement streamlines setup by matching the way engineers think about real-world structures, distributing weight evenly along each beam, or applying a single combined load to multiple members. For users, that means less manual work, fewer errors, and more accurate results, whether you're validating a lightweight frame, testing a truss under heavy loads, or ensuring your design meets safety requirements. With these new distributed force and mass options, SOLIDWORKS Simulation 2026 makes beam analysis smarter, faster, and more intuitive than ever before. This structure is also being reviewed with response spectrum analysis to evaluate how it performs under seismic loading. To complete the setup, we need to account for heavy equipment mounted on the frame. In the past, that required modelling the full geometry, or leaving its effect out altogether. With SOLIDWORKS Simulation 2026, a remote mass can now be assigned directly in a response spectrum analysis. This allows us to represent mounted equipment as a lumped mass rigidly tied to the structure without adding unnecessary details. For engineers, this keeps the model lighter, accelerates solving, and still provides accurate results. Once the remote mass is applied, we run the study. The frame's displacement limit is 10 mm, but results show a maximum displacement of 26.36 mm, meaning a design change is required. By simply copying the study and adding 2 horizontal beams, we can quickly test a reinforced configuration. With the same alloy steel material applied to the new beams, the updated results show a maximum displacement of 2.4 mm, which is comfortably within the allowable range. With this new configuration, we need to re-evaluate buckling to understand at what load levels the structure could fail. In previous versions, buckling studies often reported negative load factors, representing load reversal and indicating instability under compression applied in the opposite direction of the defined load, which complicates results interpretation. SOLIDWORKS Simulation 2026 introduces a new option to extract positive eigenvalues only. When enabled, the solver automatically filters out negative modes and reports only the critical positive load factors. This enhancement reduces clutter, accelerates interpretation, and provides more reliable insights into when and how your beam structures could buckle. Together with our TriMech Group partners, we're showcasing the latest and greatest enhancements across the SOLIDWORKS 2026 portfolio on our dedicated What's New webpage. There you can dive deep into our blogs and videos that outline everything you need to know about the new release. And you'll also be able to get in touch with our experienced engineers for a tailored look at how SOLIDWORKS Design 2026 could boost your business.